let's take a look at some examples of applying the product rule to some functions. Our first example here is find f prime of x for f of x equal to the quantity 3x squared minus x plus 5 multiplied by the quantity x squared plus 3x minus 9. Now, as we can see that this is the product of two quantities, we will want to be using the product rule. And we've included the product rule at the bottom of the screen for a reference. So let's go ahead and see how this rule might be applied to this particular function. So to start with, we clearly identify what the two functions being multiplied are. And for reference to the product rule down below, this first factor, 3x squared minus x plus 5, we will refer to as g of x. And then our second factor we will think of as our h of x. And so as we want to find the derivative of this function, we will see that as a result of the product rule, we need both the derivative of g and the derivative of h. So let's go ahead and find those first. So g prime of x is the derivative of 3x squared, so that will be 3 times 2x to the first power, using both the constant multiple rule and the power rule, minus the derivative of x, which is 1, plus the derivative of 5, which is 0. So this ends up giving us 6x minus 1 as the derivative of g. Doing the same thing for h, so h prime of x is the derivative of x squared, which is 2x, plus the derivative of 3x. The derivative of 3x is 3 times the derivative of x, which is 1, minus the derivative of 9, which is 0. So that gives us h prime of x being 2x plus 3. And now we're ready to go ahead and find f prime of x. So f prime of x is going to be the derivative of g, which is 6x minus 1, times h, which is x squared plus 3x minus 9, plus the derivative of h, which is 2x plus 3, times the function g, which is 3x squared minus x plus 5. Now, this is what the derivative of f is, and at this point we could go ahead and distribute and multiply things out. So we would end up with something like 6x cubed plus 18x minus 54, I'm sorry, that's 18x squared, minus 54x, using the 6x in the first factor. Now, multiplying by negative 1, we get negative x squared minus 3x plus 9. So that's using the distributive property for our first pair of factors. Moving on to our second pair of factors, we will get 2x times 3x squared is 6x cubed. 2x times a minus x is minus 2x squared, and then plus a 10x. That's from distributing my 2x into my second factor. And then what remains is to distribute this 3 and then collect up like terms. 3 times 3x squared is going to give us a 9x squared. 3 times a minus x is going to give us minus 3x. And 3 times 5 will give us a plus 15. Now at this point, we need to start collecting up like terms. So I've got a positive 6x cubed, another positive 6x cubed, and those are the only x cubed terms. So we end up with 12x cubed. Now we move on to our x squared terms. We've got 18x squared minus 1x squared gives us 17x squared. 17x squared minus 2x squared gives me 15x squared. And then 15x squared plus 9x squared gives me a positive 24x squared. Now moving on to our x terms, we've got negative 54x minus 3x gives us negative 57x. Negative 57x plus 10x gives us negative 47x. Negative 47x minus 3x will give us a minus 50x. And now for our constant terms, we've got a 9 plus a 15, and 9 plus 15 is 24. So the derivative of our function, or f prime of x, is equal to 12x cubed plus 24x squared minus 50x plus 24. In our next example, we want to extend our product rule to products that contain 3 factors. Now, as we look at this product rule as it's given to us, we'll note that in the product rule, we are multiplying by the derivative of the first factor times the second, plus the derivative of the second factor times the first. So as we strive to figure out what the derivative of this function, f of x, which is equal to g of x times h of x times p of x, as we strive to figure out what that is, we'll start by considering this g of x times h of x as our first factor and p of x as our second factor. So as we do this, f prime of x is going to be the derivative of g of x times h of x times p of x plus the derivative of p of x times our g of x times h of x. So in essence, we're considering g of x times h of x as being this first factor in the product rule. So now, if we apply the product rule here, where we have the derivative of g of x times h of x, what we get is g prime of x times h of x, this is directly from the product rule, plus h prime of x times g of x. That's applying the product rule. And then that times p of x. Plus, and now when we take the derivative of p of x, we will get p prime of x times g of x times h of x. Now, let's go ahead and apply the distributive property here, where we took our first derivative using the product rule, and we would get g prime of x times h of x times p of x plus h prime of x times g of x times p of x plus p prime of x times g of x times h of x. And so what we should notice is If we look back at our original function, we can see that in the first term of the derivative, we have the derivative of the first factor in that product, and the remaining two factors are left alone. Then we're adding to that the derivative of the second factor, and we're leaving the remaining two factors alone, plus the derivative of our third factor, leaving the remaining two factors alone. So we could generalize or extend the product rule here below and say that f prime of x is equal to g prime of x times h of x times p of x plus h prime of x, derivative of the second factor, multiplying by the other two original factors, plus the derivative of the third factor, multiplied by the other two original factors, h of x and g of x. So this provides us a rule that can be applied when we have three factors in our function. And in fact, this same process can be extended to functions who have more than three factors. So let's use this new version of the product rule to help us find the derivative of f of x equals x squared times quantity x cubed minus 2x times e to the x. So here we go. So f prime of x will be the derivative of our first factor, which is 2x, times the remaining two factors in their original form, plus now the derivative of our second factor, which is 3x squared, using the power rule, minus 2 times 1, times the other two factors in their original form, and then plus the derivative of our third factor, our e to the x, times, which is e to the x, times our original two factors, x squared and x cubed minus 2x. So there's our derivative. We can clean this up a little bit. So let's go ahead and do that. I have a common factor of e to the x in each of my terms. So let's go ahead and factor that out. So we'd have e to the x times, and then for this first term, let's go ahead and use the distributive property. So we'll have 2x to the fourth minus 4x squared. Moving on to our next term, plus 3x squared minus 2 times x squared. Let's go ahead and use the distributive property on that, like so. So rather than what I have there, we would have 3x to the fourth minus 2x squared. And then plus from our last and final term, when I factor out the e to the x, let's go ahead and use the distributive property there as well. And we'll have x squared times x cubed, which is x to the fifth, minus 2x cubed. And we can continue to clean that up just a little bit more. We will have e to the x times the quantity. Now, collecting up like terms in my brackets, I have a single x to the fifth, Looking at x to the fourth, we have 2x to the fourth plus a 3x to the fourth, so plus 5x to the fourth. X cubed terms, it appears we have one of those, and that's a minus 2x cubed, so minus 2x cubed. And then now looking at x squared terms, we have a minus 4x squared and a minus 2x squared, which should give us a minus 6x squared. And that takes care of all of those terms. So the derivative of our function f of x equals x squared times the quantity x cubed minus 2x times e to the x, using this new rule we've derived, is f prime of x equals e to the x times the quantity x to the fifth plus 5x to the fourth minus 2x cubed minus 6x squared. I hope this helps.